everyone, I am Harsh and today we are going to discuss the 14th problem from CP-31 sheet by TLE Eliminators under the 1100 rating range. So let's move on to TLE Eliminators website. Here is the CP-31 sheet, 1100 rating box is clicked and here is the clickable link to our problem. So let's move on to our problem. So the name of the problem is short the subarray. Let's go through the problem. So monocarp had an array A consisting of n integers. He has decided to choose two integers L and R such that L and R both lies between 1 and n and L is lesser than equals to R, and then sort the subarray from L to R. The subarray from L to R is basically the part of the array containing the elements AL, AL plus 1, AL plus 2 up till AR, okay, in non-decreasing order. So basically you are sorting the array in non-decreasing order. After sorting the subarray, monocarp has obtained a new array which we denote as, let's suppose, A dash. For example, if A is this and monocarp has chosen L equals to 2 and R equals to 5. So see, from 2 till 5 the array is sorted, and if we just sort the elements from 2 till 5, you will see the elements are 3, 4, 4 and 7, right? So it will come in sorted order. So elements come in sorted order and rest part of the array remains the same. Now you are given these both arrays. You are given A, you are given this A dash. Now the question is, you need to find these integers L and R such that monocarp could have chosen. And if there are multiple pairs of L and R, you need to find a one which corresponds to the longest subarray. So you are given the size of the array, the original array and the modified array. And it's given that sum of n over all the test cases does not exceed 2 into 10 power 5. So this is actually what the question for you is. If I just, if we understand it over here. So what you are given is, first of all, you are given the size of the array n. Then you are given n elements of the original array. Let's suppose the original array is 6, 7, 3, 3, 5, 4. Okay. So let's suppose the value of n which was given to you was 6 and this was the original array A. And there is a modified array given. Let's suppose the modified array is 6, 3, 3, 5, 7, 4. This is the modified array. Okay. Now, you have to tell the values of L and R, for which if you choose the subarrays from L to R in the original subarray, you will get the, and sort that particular subarray, you will get the modified subarray. For example, in this particular question, if I choose L as equals to 2, and R as equals to 5 and just sort the L subarray from 2 to 5 in of the original subarray. So if the original array was this 6, 7, 3, 3, 5, 4 and I took index 2 to 5 and sorted this part of the elements, this part of the array, that is this part of subarray, I simply sorted. So what will I obtain? What will be my modified array? Do you all agree that my modified array will be 6, 3, 3, 5, 7 and 4. I simply sorted these elements, right, and placed it over here. So this is what I obtained. This array is something given to me. This is a modified array that is given to me. So you need to tell the values of L and R. And the question says that if there are multiple values of L and R for which this modified array is possible, if multiple values of L and R is possible, then you need to tell the values of L and R such that the length of the subarray is longest. Length of the subarray that you chose, that is basically R minus L plus 1, the length of the subarray is longest. Okay. So this is the question. So how we can do this? So before proceeding with the solution, let's discuss the expected time complexity. So if you look, the value of n is of the order of 1e5, right? So any solution that works in big O of n or big O of n square root n or big O of n log n or basically big O of square root n or anything lesser than equals to big O of n square root n will definitely work. But if you are having any solution that is working in big O of n square or big O of n square log n, that is anything greater than n square, this will definitely not work, right? So you have to design a solution that works within this time constraint. Cool. So how we can do this? So tell me, if I simply take the original array only 6, 7, 3, 3, 5, 4, how we can actually build our intuition. 675 67 33354 67335. This was the original array, and the modified array given to me was 633574. Okay. Now tell me one thing. Just try to think and tell me. If I tell you that have you made any change at this particular index, like if I tell you that you are choosing some LNR, and I simply ask you, tell me the first index that can be chosen, that is, tell me the value of L. How will you decide that? See, over here the values are same, right? In the main array also and in the modified array also the values are same. At this particular index, in the main array and in the modified array, the values are different. What does this imply? This implies that this particular index is included in my subarray L2R, because this particular index has been modified. The value at this particular index has been modified. This implies that this particular index is included in this subarray L2R, isn't it? And this was also the first index that I got from the left, right? So I can say that, okay, this is my L. Okay, great. So let's move on to the next index. Is this included? Is this included? May or may not. Is this included? Yes. Is this included? Yes. Because the indexes for which the values in the main array and the modified array are different, those indexes are definitely included, right? Now see, tell me the last index that is included. Tell me the value of R that can be the possible value of R. This must be the possible value of R, right? Do you all agree? This must be the possible value of R, because this is the last index. This is the last index for which I got that the value in the main array and the value in the modified array were different, right? So I can say that, okay, my L is equals to 2 and my R is equals to 5. This is one way of thinking this, okay? You can think like this, right? Because the indexes that contains different value in the main array and the modified array, they definitely are included in my subarray L2R. Now since this is included, this is included, this is included, so this has to be included. This index has to be included, though it is not necessary for it to be included, but this has to be included because the subarray is always continuous, right? So this is how actually we can solve this question, but there is a check. What is the check? The check is that they have told you that if there are multiple values of LNR, you need to output LNR such that the length of the subarray is longest. What does that actually imply? See, if I tell you that my main array was, let me modify the example a bit. If I tell you my main array was 6, 2, 7, 3, 3, 5, 4, okay? And if I tell you that my modified array is 6, 2, 3, 3, 5, 7, 4. Now what you will do? You will say that, okay, this particular index is the first index that tells that, okay, the value in the main array and the modified array are different, so it must be included in the subarray. Similarly, this is the last index that tells me that the values in the main array and modified array are different, so this index should be included in the subarray, and this is the last index that tells me like that. Cool. So what I can say is that, okay, if I take this particular subarray and sort this subarray in my original array, I will get this modified array, right? This can be told. Now tell me one thing. If I choose L as 3 and R as 6, this is what I have chosen over here. My value of L is equal to 3, my value of R is equal to 6. This is what I have chosen. If I choose the value of L as equal to 2 and R as equals to 6 and sort this subarray in my original array, tell me what will be my modified array. This is the original array, right? If I simply sort this, the part from index 2 till index 6, what will be my modified subarray that I will obtain? Do you all agree that the modified subarray that I will obtain is nothing but 6, 2, 3, 3, 5, 7, 4, which matches the modified subarray that is given to me, right? Now, why did this actually happen? This happened because though the values at this particular index in my main array and the modified array were same, but I can choose this particular index. Why? Because after sorting this particular subarray, the array that I obtain, in that the first value is greater than this value. The first value is greater than this value. This means that even if I would have chosen subarray as this, instead of choosing my subarray as this, I would have obtained the same result, because actually what I am doing, I am sorting the entire subarray and placing it over here. So even if I include this element after sorting, this particular element will come over here only, right? So this is actually how we can solve this question. How we can actually solve, the approach will be that we are given the main array A1, A2, A3, A4, A5, A6, let's suppose 6 elements, and we are given the modified array A1 dash, A2 dash, A3 dash, A4 dash, A5 dash, A6 dash. Okay. Now let's suppose this was the first index at which we observed that there was a change in value, and this was the last index. So I know that this subarray is short being sorted, right? This will be our answer. Now our aim is that if we can increase the length of the subarray, how we can do that? We will just start iterating in this modified array from this particular point till the left, till we get that, okay, if let's suppose A2 dash is lesser than A3 dash, what does this imply? This implies that we can take our subarray as this as well, right? We can take our subarray as this as well, because if we sort this subarray, and since the values A2 and A2 dash are same, and A2 dash is lesser than A3 dash, so definitely we will obtain this same subarray as the modified array, right? So the things will be same. Similarly, we can keep on doing this until we acquire the condition that, okay, the particular value, let's suppose some particular AI dash is greater than AI plus 1 dash. If we obtain this thing, then we will not proceed further. Like for example, if we let's suppose have an array as 6, 3, 2, 3, 3, 7, let me take this, 7, 3, 5, 7. Let's suppose this is my array, and let's suppose this is my modified array, 6, 3, 2, 3, 5, 7, 7. Okay. Now, by looking at the indexes, the values different. So this is the first index at which the values in the main array and modified array are different, and this is the last index. So I know I need to take this particular subarray, sort it and place it over here, and you will obtain this modified array. Now looking in the modified array, we can see that this value is lesser than this value, right? So we can take our subarray this as well. So we will get the same modified array if we simply sort this subarray, right? But can we take this particular index? Can we take our subarray as this? We can't, right? Because if we do so, the modified array that we will obtain is 6, 2, 3, 3, 5, 7, 7, because I sorted simply this part, and it is not same as the given modified array. So we can't do that, right? This is something that we can't do. So we can't take this subarray. The maximum we can take till the left is this. We can extend our subarray towards the right as well, isn't it? Because in the modified array, this value is 7. And the next value is also 7. So even if I take my subarray as this, and I sort this, so I will get the same modified array, right? So this is how actually, by looking at the first change and the last change, we can get the short subarray that will definitely be sorted, and then we can extend this subarray towards the left and towards the right till the condition prevails. And this is how actually we can get the longest subarray. We can get LNR for the longest subarray, on sorting which in the main array we will get our given modified array, right? So this is how actually we can solve. So let's jump on to the code. This is actually the code to this problem. So first of all, I took the number of test cases as input, then took n as input and constructed two arrays, the main array and the modified array. So the main array is ARR and modified array is ARR2. Okay. So then both are of size n. Then I took input of both the arrays. Now there are two values, change1 and change2. So change1 basically tells me the first index at which we got the different value in the main array and the modified array, and change 2 tells me the last index at which that was found. So I initialized both of them with -1. Okay, I simply started iterating. If ARR of I is not equal to ARR 2 of I, that is at this particular index the values are not same. So if I have not modified my change 1 till now, so I am writing my change 1 as I, else I am writing my change 2 as I, and I am simply breaking. Okay, why is this so? If my ARR I is not equal to ARR 2 of I, what does this mean? This means that the value at that particular index are different, right? So if my change 1 is equals -1, if my change 1 is equals -1, what does this mean? Doesn't it mean that I have not got my first index till now at which the values were different? So what I will do is I will assign change 1 as I. Else what I will do? I will assign change 2 as I, that okay, I have got the first index. Now this is the second index at which I got something like this, and then I will simply break. Then I simply assign my I as change 1 -1. Why I am doing so? Because I know that if I get a change 1, I need to extend my subarray towards the left, right? So what I am doing is, while my I is greater than equals to 0, if ARR 2 of I, that is in the modified array at index I, if it is lesser than equals to index I plus 1, this means that okay, I can include this particular index I as well. So I am simply doing I minus minus, else I am breaking. And at the end, whatever I obtain, what does this mean? If I am doing like this, if I am telling that this is a subarray that I can take, this is my change 1. Okay, and I am standing at this particular index I. This is my I. I will try to see that whether I can take this index I as well or not inside my change 1. Let's suppose I can take this I. So I can take this subarray, I will shift my I over here. Then I will shift my I over there. I am simply decrementing my I. Now the last I at which I can't take, I will simply break. So tell me, from where I can take my subarray? From I plus 1, right? Because this is the last I at which I can't take my subarray. So what I did was, after coming out of this while loop, my change 1 will become I plus 1. Now, if my change 2 is -1, what I am doing is I am assigning my change 2 as n minus 1. Why I am doing so? See, let's suppose you are at A1, A2, A3, A4, A5. You got this as your change 1, and in the modified array, this was your, let's suppose, modified array A dash. The first value was same, second value was, let's suppose, different, and rest 3 values were exactly same. So will you get change 2 ever? Will you get change 2 ever? The answer is no, right? So what you do if you don't get change 2? If you don't get change 2, you can say that okay, this last index is your change 2, right? This last index is your change 2. That is something that you can do, because you want the longest subarray that you can take, right? So if you want to take the longest subarray from this, so that when you sort the values you get the same subarray, so you can definitely take the last index as change 2, because the values in this subarray are exactly the same, right? So what I am doing is, if change 2 is -1, assigning my change 2 to n minus 1, then I am telling, then I will try, if let's suppose my change 2 was not -1, my change 2 was some particular index. So I will try to extend my subarray towards the right as well, right? So what I am doing is, I am assigning my j as change 2 plus 1, while j is lesser than n, the same case as we did while extending towards the left. I will just break at the last j at which I can't take. So if ARR 2 of j is greater than ARR 2 of j minus 1, I will keep on simply incrementing my j till my j is lesser than n, else I am simply breaking. And what will be my change 2? My change 2 will be j minus 1. That is an index just before, the index just before I can't take. That is, j was the index at which I can't take, the last index at which I can't take. So index just before that will become my change 2, that is basically r. Now since you need to print LNR in 1 based indexing format, and everything we have considered in 0 based indexing, so I am simply printing change 1 plus 1 and change 2 plus 1, and then a new line for the answers for the new test cases. So this is how actually we are writing this code. So code seems a bit long, but if you just go step by step that what does change one and change two means, this part is something that we are extending our array towards the left, this is something that we are extending our subarray towards the right, something like this. So you will definitely get the case. Okay. What's the time complexity? If you look for every test case, this loop runs for n, this loop again runs for n, this loop runs for n, then this loop runs for n at max, and this loop runs for n at max. So we can say that okay, the time complexity is for every test case, the time complexity is big O of n. What's the space complexity? If you look, we are constructing two arrays, right, of size n. Rest we are not utilizing any other space, so we can say that okay, the space complexity is also big O of n. And once you understand this, you will be good to go. So I hope all of you got it. Thank you.